Hello and welcome. In this lecture, let's become less theoretical and more practical and discuss about determining the centroid of composite plates and wires. Now, in most practical cases, the flat plate or a wire can be divided into simpler areas, like for example rectangles or triangles or circles, for which we know their centroid, their location of the centroid. We know that. And then based on that, we can then easily determine the centroid of the entire composite plate. So, as before, let's look at a situation in which we have a flat plate that is homogeneous and has uniform thickness and a total area of A, and it's contained in the XY plane. And we're trying to determine its centroid. So in other words, we're trying to determine the coordinates of the centroid, which would be X bar and Y bar. Now, we can do so by dividing this plate into a number of simpler areas. As I said, they could be rectangles, triangles, circles, arcs of circles, and so forth. In this case, we can divide this plate into 2 triangles and 1 rectangle, as shown. And the good thing is that for each of these areas, we actually know the location of their centroids. So C1 will be located at X1 bar, Y1 bar, C2 be located at X2 bar, Y2 bar, and C3 will be located at X3 bar, Y3 bar. We also, of course, know the individual areas of these elements. And then for equivalence for these two systems, we have to apply the same equations as before, but now because we don't deal with infinitesimally small little elements, but with larger defined areas, we can replace the integrals with real summations. So the first moment I vary about the x-axis will be equal to y bar a and sum of y I bar times a, and the first moment of area about the y-axis will be equal to x bar a, and that will be equal to summation of xi bar times a. So as you can see, much simpler, because now we replace the integrals that we had to deal before for general areas with simple summation of numbers. Much simpler and straightforward. So therefore, for a homogeneous, flat, composite plate of uniform thickness, we can solve from the equations of the first moments of the area for the centroids, for the coordinates of the centroid of the entire plate. So that would be capital X bar equals to sum of xi bar ai divided by the total area, sum of ai. And capital Y bar equals, in a similar way, to sum of yi bar ai divided by the entire area of the plate. So very simply, with these two expressions, we can determine the coordinate of the centroid of the composite plate. Now, there are a few things that you need to remember. The first and very important thing is that these coordinates that we've just calculated will depend on the system of coordinate axes that is selected for reference. So if you select a different system than your colleague, you will get different numbers, different results, although both numbers, yours and your colleagues, would be most likely correct. So everything is relative to the system of axes. Then when you input the numbers into this formulae, you have to use the correct sign for xi bar and yi bar depending on their relation with respect to the system of coordinate axes. And also sometimes you may have to deal with holes like missing plate material, and these holes, when you calculate their areas, you have to take these areas as negative, so with a negative sign, because there's no material there, the material is missing, so hence the negative sign. Now secondly, if we talk about lines, so for a homogeneous flat composite wire that has a uniform cross section, in the same fashion as before, we will have now to divide the line into simpler elements, same as we've done with the area. So we can divide the line into maybe straight lines or arcs of a circle and so forth. And for these lines, we of course know their length, and we also know the location of their centroids. Therefore, based on the same theory, we can now determine for lines, for wires, we can now determine the coordinates of their centroids in a similar fashion. So sum of xi bar li divided by the entire length of the wire will give us capital X bar, and sum of yi bar li divided by the entire length of the wire will give us the y coordinate of the centroid of the line or wire. So that's basically the theory. That's what we're going to apply in the future problems, and in the next lectures we will look at a couple of examples to see how we can apply this theory. Thank you very much for watching this lecture, and I will see you at the next one.